Good morning all of you. In the previous class we are solving the questions based on limits. So let's continue the class taking questions of your NCERT book and we will solve it. Let's see. Question number 15. Exercise 13.1. Okay, so let limit x tends to pi sin pi minus x upon pi minus x. Okay, we have to find the limit of this function. So what we will do first we will take this term, let pi minus x is equal to theta. So as x tends to pi, then theta tends to 0. So change the limit theta tends to 0 sine, and this is theta upon this is pi theta. So 1 by pi limit theta tends to 0 sine theta by theta, and you know the value of limit theta tends to 0 sine theta by theta is 1. Okay, so 1 by pi into 1, that is 1 by pi. This is answer. Okay, what we have done, we have taken this pi minus x is equal to theta. Okay, after this we have taken x tends to pi, we have to give it. So now we change the limit. If x tends to pi, then theta is equal to 0, so theta tends to 0. Now put the value, theta tends to 0. Okay, sin theta by theta, and this is pi theta, so take 1 by pi is outside, limit theta tends to 0 sin theta by theta, and the value of this term is 1. So our answer is 1 by pi. Let another question. Question number 17. Limit x tends to 0 cos 2x minus 1 by cos x minus 1 is, we have to find the value of this limit. So let limit x tend to 0, we can write this what, taking minus common, 1 minus cos 2x 1 minus cos x, this is cancelled. Now limit x tends to 0, this is what, 2 sine square x, and this is 1 minus cos x. Now limit x tend to 0, 2, we can write 1 minus cos square x upon 1 minus cos x. Limit x tends to 0, we can write this 1 minus cos x 1 plus cos x upon 1 minus cos x, and this is cancelled. Put the value of limit, so we get 2 1 plus cos 0. This implies 2 into 2 is equal to 4. This is our answer. Okay, first we have changed this cos 2x minus 1 upon cos x minus 1. Okay. Now this is cancelled, taking minus outside. 1 minus cos 2x, 1 minus cos x, 2 sin square x, and this is 1 minus cos x. Now this is sin square x, we can write 1 minus cos square x. So 1 minus cos square x, here we can write 1 square. Now in first bracket a minus b, in second bracket a plus b. Now this is the cancel, and the remaining term is 2 1 plus cos. Put the value of limit is 0, so we get 2 into 2 is equal to 4. Next question. Question number 18. Limit x tend to 0 ax plus x cos x divided by b sin x. Okay, ax plus x cos x plus b sin x. So let's solve this. Limit x tend to 0, taking x outside, we get a plus cos x by b sin x. Now limit x tend to 0, a plus cos x b sin x upon x. Okay, so we can write limit x tend to 0, a plus cos x by b limit x tend to 0 sin x by x. Now put the value of this, so we can write limit now this is a plus cos 0 upon b into 1. So this is cos 0 is 1, so a plus 1 by b, this is our answer. Okay, first we have taken x outside, a plus cos x upon b sin x, a plus cos x upon b sin x. This sign will be inside. So limit x tend to 0, a plus cos x, again limit x tend to 0 sin x by x. So this is the value of 1. So a plus cos 0 is 1, so a plus 1 by b. Now we will see the next question. Next question is question number 20. Limit x tends to 0 sin ax upon ax plus sin bx. Now we have to find the limit of this function. Okay, so first limit x tend to 0, we will take common x from numerator. We get sin x by x plus 1, and taking x from denominator, sin bx upon x, this will be cancelled. Now take the limit to the numerator and denominator both. We get limit x tend to 0 sin ax by x plus a upon limit x tend to 0 a plus sin bx by Okay. Now we will multiply here with a into a. Into a. Okay. Here is bx, so it will be b, and here is sin bx. So we get here b. Okay. Now this is constant, so we take limit x tend to 0, a sin ax by ax plus b upon limit x tend to 0, a plus limit x tend to 0, multiply here with p and b, we get sin bx by bx into b. So the value of this is 1 and the value of this is 1. So we write 1 into a plus b upon a plus 1 into b, that is a plus b by a plus b, which is 1. Okay. What we have done, we have taken x from numerator and x from denominator outside, both will be cancelled. Okay. Limit x tend to 0, a sin ax by ax plus b, we have multiplied and divided with a, again we multiply and divide with b, we get this term, limit x tend to a, x tend to 0, sin ax by ax into a plus b, limit x tend to 0, a, limit x tend to 0, sin bx by bx, this is 1. So 1 into a plus b, a plus 1 into b, so a plus b upon a plus b is equal to 1. Okay. Now we will see the next question. Next question is question number 21. Limit x tend to 1 cosec x minus cot x. We have to find the limit of this function. So limit x tend to 1, this is cosec x minus cot x so we can write divided by 1. So limit x tend to 1 cosec x minus cot x by cosec square x minus cot square x. We can write the identity. So limit x tend to 1 cosec x minus cot x cosec x plus cot x cosec x minus cot x. Okay. Limit x tend to 1. Now this is cancelled. So you get 1 by sin x plus cos x by sin x. We get limit x tend to 1 sin x by 1 plus cos x. Okay, we can write this. Now we have to given the limit x tend to 1. So our limit is x tend to 0. Okay. Now put the value of limit is sine 0 by 1 plus cos 0. So 0 by 2 is equal to 0. Okay. Now we will see the next question. Next question is (22). In this question we have to given limit x tends to pi by 2 tan 2x upon x minus pi by 2. Okay. So first, if we are putting the value pi by 2, we are getting the form 0 by 0. So let this x minus pi by 2 is equal to h. Okay. So as x tends to pi by 2, then h tends to 0. If we are putting x by 2 at x, then we get h tends to 0. Now replace limit h tends to 0, tan 2 under bracket. So we can write the value of x pi by 2 plus h. Put pi by 2 plus h. Now this is h. So replace this with h. Now limit h tends to 0, tan 2 into pi by 2 plus 2h by h. H tend to 0, tan pi plus 2h by h. Now tan pi plus theta. What is tan pi plus theta? Tan theta upon h. Limit h tend to 0. Okay. Now what we will do? Limit h tend to 0, tan 2h by 2h into 2. Okay. Now the value of this is 1 into 2, that is 2. Okay. So it will be our answer. Now see, once again we have taken this quantity h. If we are taking the limit x is equal to pi by 2, we are getting what? H tend to 0. Now we get from here the value of x is pi by 2 plus h. Put the value in the limit. H tend to 0, tan 2 pi by 2 plus h by h. Multiply this 2, we get 2 into 2, cancel, pi plus 2h. Limit h tend to 0, tan pi plus theta upon h. Now this is tan pi plus theta is tan theta. Okay. So tan 2h by h. Now we can write tan 2h upon 2h into 2, and this is the value 1 and 2. So the value is finally 2. Now the next question. Question 23. find limit x tend to 0 fx. Okay, and we have to given fx is what? Fx is 2x plus 3 comma x is less than equal to 0 and 3 x plus 1 x is greater than 0. Okay, now we have to find the limit this. So first we will find the left hand limit, then right hand limit. If the left hand limit and right hand limit will be equal, then we will say that the limit exists. So the value of limit x tend to 0 fx will be okay. So first take left hand limit x tend to 0 minus fx. Now limit x tend to 0 f 0 minus h. Limit h tend to 0. Okay, so x is less than 2, so we can write 2 0 minus h plus 3. Now value of this is what? Put the value h is 0, so it will be 3. Now take right hand limit. Limit x tend to 0 plus fx. Limit h tend to 0 f 0 plus h. Now when x is greater than 0, the function is this. So let limit h tend to 0 3 0 plus h. Okay, so the value h is 0, so we are getting again 3. So limit x tend to 0 minus fx. Limit x tend to 0 plus fx is equal to limit x tend to 0 fx, which is 3. Okay, now we will see the next question. Our next question is look at what I have done. Limit x tend to 0 minus left hand limit fx h. So we will replace this now. H tend to 0, so we write here 0 minus h. Now where is x? We will put 0 minus h. Here is x and this is less than, so it is left hand. So we write 0 minus h, so we get 3 and limit x tend to 0 plus fx. Limit h tend to 0 f0 plus h. 3 0 plus h. Taking right hand limit, so x will replace 0 plus h plus 1. This is 3. So both are equal, so limit will be 3. Now next. Limit x tend to 1 fx. We have to find this, and given fx is what? X square minus 1 x is less than equal to 1 minus x square minus 1 when x is greater than 1. Now again we have to find the value of this limit, and we have to given the function. Now what we will do? We will take the left hand limit. If the left hand limit and right hand limit will be equal, then we can find the limit of this function. If not equal, then the limit does not exist. So left hand limit x tend to 1 minus f x. Now limit h tend to 0 f 1 minus h. Limit h tend to 0, x is less than here, and the limit is, the function is x square minus 1. So we can write 1 minus h square. So the value is, if we are putting h is equal to 0, okay, so here 1 minus 1 is 0. Now right hand limit x tend to 1 plus fx. Limit h tend to 0 f1 plus h. Limit h tend to 0 f1 plus h, and this is greater than 0, so minus 1 plus h square minus 1. Now put the value of limit, we get minus 1 plus 0 square minus 1, so it will be minus 2. Okay, so left hand limit is not equal to right hand limit, so the limit of the function does not exist. We can write limit x tend to 0, x tend to 1 minus fx not equal to limit x tend to 1 plus fx. This implies limit does not exist. Okay, so we can write limit does not exist. So if the left hand limit and right hand limit is not equal, then we can say that the limit of the function does not exist. Look at what we have done. We have to find limit x tend to 1, fx is equal to how much, and the given function is this. When x is less than equal to 1, then the function is x square minus 1. X is greater than equal to 1, then greater than 1, then function is minus x square minus 1. First we are taking left hand limit x tend to 1 minus fx. Now we write h tend to 0, 1 minus h, and for left hand limit x is less than, the function is this, x square minus 1. Okay, so we write 1 minus h square at the place of x is 1 minus h, because here at the place of x is 1 minus h, so 1 minus h is whole square minus 1. If we are putting h is 0, so here is 1 square, 1 minus 1, that is 0, which is our left hand limit. Now the right hand limit x tend to 1 plus fx, and limit 1 plus fx, and for x is greater than 1, the function is minus x square minus 1. So we can write limit h tend to 0 f1 plus h. Limit h tend to 0 is minus x square, so 1 plus h whole square, because here is x, at the place of x is what, 1 plus h, so we can write 1 plus h whole square minus 1. Now we have to put the limit. If h is equal to 0, so here is 0, now is squaring, so we get 1. Now we can write minus 1, that is equal to minus 2. Okay, now we are saying that our left hand limit is this and right hand limit is this, both are not equal, so we can say that left hand limit is not equal to right hand limit, means limit x tend to 1 minus fx is not equal to limit x tend to 1 plus fx. So if the left hand limit and right hand limit not equal, then we can say that the limit of the function does not exist. If the left hand limit and right hand limit are equal, then we can say that the limit of the function is exist. Okay, now next question we will see in the next class. Okay, thank you.